All right, let's do a quick review of imaginary numbers. We call I the imaginary unit, and here is the cycle of I, remembering that I equals the square root of -1. So if you square that, you're going to be getting rid of that root, and you get 1. Anytime you have I squared, it's -1, and then in this case there's one additional I left since it's I cubed, so you're going to get -I. And then finally, when you have I to the 4th, you really have I squared times I squared, which is -1 times -1, and that brings you the whole way back to 1. There are two types of numbers that we're going to be talking about: pure imaginary numbers and complex imaginary numbers. Pure imaginary numbers are only multiplied, so there isn't a plus or a minus as part of them. They're only an imaginary number, therefore pure imaginary number. Complex numbers contain a real part and an imaginary part, and you will see a plus sign or a minus sign. The real part always comes first, and the imaginary part always comes second. So let's do a couple of examples here. First, we just want to look at how we're coming up with these imaginary numbers in a very simple way. So let's say we have x squared plus 121 equals 0, and we want to solve for x. So x squared equals -121. Square root of both sides. Now I have x. I have the square root of -1 times the square root of 121. Square root of 121 is 11, and the square root of -1 is I. And we have to remember that this is plus or minus 11i, because when we plug that value into x, either the positive or the negative value will in fact give us the correct answer, because anything that is squared ends up being a positive value. So -11i squared will give me the positive value. Positive 11i squared will give me the positive value again. So, for example, if I work this backwards, I have 11i squared plus 121 equals 0, and then we have 11 squared is 121, I squared is -1 plus 121 equals 0, so 121 times -1 plus 121 equals 0, -121 plus 121 equals 0, so that checks out. And then for the negative value, -11i squared plus 121 equals 0. So -11 squared is 121 I squared plus 121 equals 0. And I'm right back to where I started up here, so I'm not going to spend any more time on this problem. In terms of how we combine and work with imaginary numbers, I can add and subtract them. I can also multiply and divide them. So let's just say I want to subtract two complex numbers. First thing I need to remember, and probably the most common mistake, is that I have this negative sign here, so I'm going to switch my signs, and I'm going to do that before I do anything else. And then I'm going to combine like terms. So -4 and -3 is -7, and -6 and -2 is -8. And I've put my real number first and my imaginary number second. And that is written in correct form. Let's say I want to multiply. So 2 minus 2i, 3 minus 5i. So I'm going to FOIL here. So 2 times 3 is 6. 2 times -5i is going to be -10i. -2 times 3 is -6i. And then -2i times -5i is going to be plus 10i squared. Now we need to simplify, and we recall that I squared is equal to -1. So now I'm going to have 6, I'm going to combine my like terms here, minus 16i plus 10 times -1, so it's really minus 10. And then I'm going to combine like terms again, making sure that I put it in correct form. So real number first, imaginary number second. Now when I need to divide, we have some kind of special rules with dividing complex numbers. Anytime I divide a complex number, I'm going to have to use the conjugate. And the reason I want to use the conjugate is because every time I FOIL, my middle terms or my I terms are going to cancel out. And that'll give me a real number term and an I squared term. And that way I will be able to get my imaginary number, my I, out of the denominator, because I have to get my imaginary number out of the denominator. So go ahead and pause this if you need to continue looking at the steps. I'm going to do a couple examples. So let's say I have 7 over 3 plus I, and I need to write it as a complex number in standard form. So I need to have this I out of the denominator, and I need to have it as real number plus or minus imaginary number. So I'm going to multiply by the conjugate, remembering that anytime I multiply something when it's the same in the numerator and the denominator, so 3 minus I in this case over 3 minus I, that is just like multiplying by 1, and therefore does not change my expression. So I'm going to distribute in the numerator, so 21 minus 7I, and then I'm going to FOIL in the denominator, so 3 squared, 3 times 3 is 9. I'm going to be minus 3I plus 3I, which is the whole purpose of this process, and then minus I squared. So those two middle terms cancel out, and I have 21 minus 7I. Remember that I squared is -1, so I have 9 minus -1. And so that's going to be 21 minus 7I over 10. If I have a little bit more difficult one, let's go ahead and do this example here, which is a little bit more challenging. Okay, so we have a lot going on here. So first I'm going to combine like terms in the numerator and the denominator. So I've got 9 minus 5I and -6 plus 8I. Now I need to multiply by the conjugate. So -6 minus 8I, or -6 minus 8I. Okay, so in the denominator, remembering that my I terms are going to cancel out because that's the whole purpose of multiplying by the conjugate, I have the square of the first number minus the square of the second number, the difference of squares. And then in the numerator, I'm going to go ahead and FOIL. All right. Now, every place I have an I squared, I can substitute in a -1. So now in the numerator, that will end up being minus 40 because I squared is -1, and 36 plus 64 in the denominator. So then I end up with 94 minus 42I over 100, and I can reduce and I lost my negative right there. So my final answer is going to be -47 minus 21I over 50.